Okay, so in this video I want to talk about multiplying binomials that are composed of sum and difference of two terms. So the rule for that is that if you have like a plus b, so the term a plus the term b in one parenthesis and then a minus b, so you're multiplying the sum and the difference of the same values, then this becomes a squared minus b squared. I'm going to go ahead and first do an example by doing the long multiplication, and then I'm going to go ahead and do directly using the rule. So this is the rule for sum and difference of the product of sum and difference of the same terms. This is also known as the difference of squares, because at the end we have two squares being subtracted, but you're gonna see that in your future math courses. So for the first example, we have k plus 7 times k minus 7. Now we know that this, if we use the rule, will become, this is like your a value, and this will be like your b value, right? So it will become k squared minus 7 squared, right? Which is k minus 49. Now let's go ahead and do it the long way. So I'm going to go ahead and multiply k times k. So k times k, that's k times k, and then k times negative 7. And then positive 7 times k, and then positive 7 times negative 7. So on the first one we have k squared, and then minus 7k plus 7k, and then minus 49. So we notice that the terms in the middle will cancel out because we have negative 7 plus 7k, which is 0k. And we're left with k squared minus 49, which is actually the same as this, right? So the rule is just an easier way, right, to avoid all the FOIL or the distributive property within the two binomials. So we can just say that a k plus 7 times k minus 7 equals k squared minus 7 squared, which is k squared and then minus 49, right? That's just an easier way of solving it. Let's go over another example. Now let's say that for this next one we have 3c squared plus 4 times 3c squared minus 4. So if we use the rule, this will become, because we have 3c squared, right, that will be like our a term, then this is 3c squared square, right? And then we have 4 as our b term, so minus 4 squared. So this is a squared and then b squared. So for the first term, the square will be distributed, so we are going to have 9c to the 4th minus 4 squared, which is 16. Okay, let's try one more. We have a plus p times 8 minus p. So 8 will be our a term and p is our b term. So again, both binomials need to have the same a and same b, right? So same value. So we will have 8 squared minus p squared, which is 64 minus p squared. And that's the end of the multiplication between these two binomials.